All right. So, hey, everybody. I'd like to introduce Michael Behrisch from German Aerospace Center. So they've been developing the SUMO transportation model that accounts for, I think, pretty much every car in the road in the city, which is an incredible level of detail. So, thank you. Welcome, Michael.
Yeah, thank you, Greg, for the nice introduction, and thank you to all of you to the invitation. And yeah, I will try to give an overview of what SUMO can do in general, and if you get bored at any point of my presentation, and just feel free to download it in parallel. We'll have a short hands-on at the end, so that you can try it out together with me. But of course, you can also do this later on. And yeah, just clicking on the wrong slide. Okay. So what exactly is SUMO? So as you can probably tell from its look, it is already, let's say, a fairly old project, in the sense that we started developing it in 2001. I myself are here at German Aerospace Center since 2007. Let's say I was the second one who did this full time. So in the first 6 years, it was basically a one-man project. And the look is still very much Windows 95, as you can see from the screenshot. But let's say the nice thing about our graphical user interface is it looks the same ugly way on all platforms. So it does support Linux, Windows, and macOS at least, and basically everywhere you can compile it. We hope it will run. So we had also people trying this on Solaris, and with success. So this is the graphic user interface is Fox Toolkit. Probably no one of you uses this, but yeah, at least it works. So what was the idea when we started? We need traffic simulation because we are a traffic research institution here at the German Aerospace Center. And let's say the major question at the beginning was, whenever someone did traffic simulation, they developed their own model, because it is not too hard to do. I mean, you can start from a single car following another car, and yeah, everyone thinks that, I can do this in 10 lines of code, and basically you can, but it gets messy quite fast, and that's why we thought, well, it would be nice to have an open source project where people can share their models and develop them together. And it grew from only doing streets to adding freight, adding public transport, and then people came and said, well, we do not want to paint all our streets by hand, so we added importers for OpenStreetMap, for OpenDrive. And let's say the first people who took this up, as usually if you start an open source project, first to pick this up are the computer scientists and not the traffic scientists. So it was very early on that people said, we need some API, we need something to interact with running simulations. And that's why when Tracy was born, which stands for Traffic Control Interface. It was intended as an, let's say, general interface, not only adaptable or not only usable with SUMO, but with other traffic simulators as well. But in fact, as of a current state, I don't think any other traffic simulator implemented this interface. So it is basically the SUMO API. Then when the project got a little bigger, and people here at German Aerospace Center asked, so where is this heading to? How do we develop this further, also organization-wide? We started to look around, let's say, how we can involve more people so that it's not only a DLR project. And that's when we started to look for, let's say, an umbrella organization to put this whole under, and that's when we started to become an Eclipse project. So it has nothing to do with Eclipse.
Did it freeze for other people?
Yes.
Okay.
Let me just send him an email.
He got eclipsed.
Clearly, yes.
Sorry, just finished on my side. I don't know why.
Weird. Okay. Welcome back.
Okay.
You were talking about the eclipse, but it's not an eclipse. I think that's where we lost you.
Yep. Okay.
Cool. Got it.
Good. Okay. So what do we do here? Or what is it for? So let's say we did not start to do this for automated driving. We started because we wanted to do traffic management. So really, the starting point was traffic flow simulation, as we call it. So you want to have, let's say, a picture of a whole city. How does traffic management influence things? How do infrastructure changes work out? Yeah. And basically do a forecast in a simulation to get to know how this works out before you need to test it in the real world. The first people, as I already said, who adopted this were people who wanted to test new technologies, car-to-car communications and things like that. That's why they needed the API, because they wanted to do vehicle messaging inside. And traffic monitoring, traffic optimization. So, of course, one of the classic points is still traffic light optimization. Still, people do this a lot. Nowadays, probably more or less often with machine learning techniques, but it's still their focus. Okay, another thing which is important, which we did a lot, is emission modeling, or we still do this, although we have to say that, let's say, yeah, you probably all heard about the problems of emission estimation in cars, especially German car makers were, let's say, not the most favorite in this respect. So let's say emission models suffer sometimes the same problems because they rely on this data, But still, tendencies you can always measure, and that's what we did here. This is one example where we did this in Brunswick, let's say a medium-sized city in Western Germany, where we really tried to restrict the inner area of the city and estimate how this changes NOx emissions. So we had the speed reduction zones of 30 kilometers per hour in the inner city. And SUMO modeled, so simulated the whole traffic, and we did estimate how this changed the pollutants. Okay, another thing we did is traffic light preemption for emergency vehicles in this case, so that they can reach the destination earlier. So in the left picture, you see what it does without traffic light preemption in the right, or in the right half of the left hand, how it works with traffic light preemption. So this is basically to show what you can do if you have a network-wide control and can easily switch early on the traffic light to green. So not only when the vehicle is very close to the intersection, but very early on to already remove all the jam which is just blocking the vehicle. So another thing which does not work. Sorry about that. This should show an automated. Okay. So okay. Yes. Now, so just to explain a little what is also inside. So SUMO is not only a simulation, in the sense that you have the simulation model and can run your city through it, but it has, let's say, a lot of tooling around it, where you can, for instance, edit the networks, import networks from different data sources. So the most prominent ones, OpenStreetMap and OpenDrive. But you can also import shape files, for instance, and then have a graphical editor to edit not only the network and the traffic lights, but also the traffic demand. So in SUMO, everything is basically XML in and XML out, but not everyone likes to edit XML files in the text editor. So for those people, we have the network editor, which also does demand editing. And NetEdit is just, by history, so to say. We have, of course, a lot of routing applications because we need to let the vehicles find their way through the network. So the three mentioned here are basically differ on their inputs. So you can either do traffic calculation based on OD matrices. So you have regions in your network and want people to move from region A to region B, and the amount and maybe a timeline of this, and want to do a traffic assignment, which does not only shortest path, but more of it, like distributing the traffic in the network. That's basically what DUA, which stands for Dynamic User Assignment Router, does. Then we have JTR router, which does junction turn ratios, and the DF router for detector flows. So if you have counting locations in your network and want to derive routes just from the counting locations, and the DF router is your tools. There's more to it, but maybe we can talk later about this. So OD to trips.
Actually, a question about that one. It sounds like you use an inverse model where, given the simulation and the measurements, you can infer what routes must be taken. Is that right?
Yes.
Okay, cool.
So that's yeah, one of the approaches, but yes, that's what people can do. So you can also try to start with a route set and then calibrate it according to the measurements, but you can also directly start only with the measurements and let the tool, so the DF router in this case, derive the routes.
Charlie had a question?
Yes. Hi, Michael. I'm Charlie.
Hi.
Nice to meet you. Thanks for doing this. Since there's not so many people on the call, I don't feel too bad about interrupting. And I have to drop off at the half past. So maybe Michael and via Greg, we can follow up separately potentially. I see I see a lot of potential to apply what you're doing to a project I'm working on, and I'm really excited about this. I just want to ask a couple quick, super high level questions. Could we import like a shipping network, like a maritime shipping network, and run that through this tool, or is that too far away from kind of what you're doing? Is one question. And then if we either imported a shipping network or created a maritime shipping network, could we then feed it like a traffic flow of like cargo, and would this tool allow us to help find routes and start simulating? Basically, can we simulate a shipping network, a maritime shipping network?
So shipping means so not ships, but transport on streets, or you really mean?
I guess I'm thinking primarily on water.
On water, ships. Okay, yeah.
But ideally, actually, a combination of trucks over the road and boats over the sea.
Okay.
Sorry, this is actually a huge diversion from the presentation. So I just wanted to be I wanted to plant the seed, and maybe we talk about it afterwards. Please don't let me like derail your entire presentation.
Okay. No, never mind. So actually, yes, we do. We also do ship simulation. We have no detailed ship model, but let's say they're basically large and slow vehicles on blue streets, more or less. And in fact, we had people doing a ship simulation even for a worldwide network in SUMO, which was, of course, not that dense, but yes, people do this. And also, if you think on a smaller scale, we, for instance, in this Brunswick example I showed, there is also a harbor in Brunswick where we did, in fact, exactly those intermodal transportation, as we call it. So where the containers changed from the train or the truck to the ship and back, and those movements are possible to be modeled with SUMO. Yes.
Good. That's great. Cool. I'd really love to follow up with you separately from that, but let's. Good exploratory question, and thank you.
Okay. Yeah, so you can just come back to me afterwards, or sumo@dlr.de is also a good contact if you can't remember my name. Okay, so yeah, we just want to finish this list shortly. So OD2 trips is just an importer for those OD matrices, but one major tool which also has, let's say, some derivations already is the activity GAN, which generates synthetic demand. So if you don't have any, let's say, real traffic demand yet, but you have population data about where people live and where people work, then you can, of course, try to generate traffic demand from that. Just by assuming that, you know, people need to move at least from their home to their workplace and back, at least if there's no pandemic around. Okay. Yeah, so maybe some data on people who use this, or how is the community. So we have about 40,000 downloads a year. So those are SourceForge numbers, whatever they are worth, I don't know, but at least they're rising. And a very active worldwide user community. We meet every year in Berlin for the annual user conference. The most recent one, unfortunately, you just missed it, so it was 2 weeks ago in September. Completely online and free in those times. Maybe we will have something in presence next year. Who knows? Okay, and if you want to scan this QR code, so then it's now your chance to get directly to the download page. So if you want to be prepared for the hands-on session at the end of the talk, then this is the point where you can already start downloading. It's not that big, but maybe you want to follow the talk on the sideline. So yeah, there is a Windows installer. There is also, as you can see, most of our users are still Windows users, but there are also Linux RPMs and Ubuntu packages and macOS, whatever you want. Okay. Okay. So, yeah, I just gave a very short overview of what SUMO does. The point where I also called this talk future mobility simulation is, you know, people driving on the highway. This picture we see here is not so hard to model, and it's hard enough. We also already put enough time in this models, but that's where you already have a lot of models. Where you know, Greg already mentioned in the beginning, you know that there are a lot of other traffic simulators which already do this. The point is more how do we simulate things like that? So very heterogeneous traffic, very different modes of transport concurrently on the street, and you know, no, or at least considerably less lane formation and driving, you know, from sideways, and also things like that. So emergency vehicles are a thing we do often or have in our SUMO simulations, because it is sometimes easier than with other simulators to directly influence the model in driving on the opposite side, or let's say making room for those vehicles to give them more room to drive the streets. And also public transport modeling and intermodal transport, so that you can change between different modes of transport in the same simulation. So this is all everything which, let's say, needs to go into a full-size traffic simulation as far as we want to develop it. We have made considerable steps in this direction. So there, let's say, SUMO has a sublane model now, which makes the heterogeneous traffic much more modelable. And as you can see here, unfortunately, he's gone now. This is the model here of the part. So intermodal transport, also with chips and trains. We did this in SUMO. One question we always get asked is, can SUMO model autonomous driving or automated vehicles? And in a sense, we always answer, yes, probably we can do this better than manual driving, because you know, of course, our cars follow a model much the way an automated vehicle does, and is, let's say, less human than the human driver in a sense. But the problem we then have is that people want to say, want to have a model where they can really distinguish that is this a human driver and is this an automated vehicle. And usually we do this by changing parameters of our model, so something like reaction time or accelerations or things like that. But it's not so much that we really need completely different models. So this is something we still work on to make this also easier for the user to distinguish this, although it may not always be necessary. Question?
Nothing, just background.
Okay. Yeah. So railways is also something, and logistics we are working on all the time. And it's something I want now to talk about is, let's say, the whole mobility on demand topic, which also took a lot of attention in recent years, so that you can model the approach of small vehicles being there when you need them, possibly automated vehicles. So essentially a taxi service without drivers, or even with drivers, which can replace or supplement the existing public transport. The problem here is that you do not have regular schedules as you have with regular public transport, so that's not a problem, of course. It's also a big bonus of the system, but it's a problem for a traffic simulation where you do not want to have them all driving the same route and the same schedule, but you do want to, somehow supply the models already to the user. So the users usually want to have, a snap-on solution that they can just say, okay, and here in this area, I have some carpooling service, and you can just use it. So I just put some persons in. I tell the simulation the person wants to go from A to B, and the simulation has to find out which car will arrive at the origin and will bring it to the destination. And of course, it needs to respect traffic conditions, choose routes, so the whole logistics, the whole assignment procedure, not only route assignment, but really trip assignment from people to the individual vehicles. That's still an active area of research, I would say, because many existing mobility providers don't share their solutions. Let's say we have models also in SUMO already which do this, but our approach here
looks like internet weather again. Welcome back. Oh, we can't hear you yet. Oh, no, oh, yes.
It seems to kick me out every 15 minutes. Okay.
Yeah, weird. All right, cool.
Okay. So, of course, people use this for machine learning and reinforcement learning, especially because, traffic is a complex topic, and still somehow everyone thinks it is somehow accessible, and everyone knows that his or her favorite traffic light is not optimal. So it's a very attractive problem somehow for machine learning, because you see the problem and you think you can improve it easily, and most of the time you actually can, because most of the traffic lights out there are far from optimal. Which is not always the fault of, let's say, the traffic research, because the research community is, I would say, ahead of the implementation on the streets by about 20 years, at least here in Germany. So it is just that the cities do not have the money or some other intentions than doing the optimal traffic light optimization algorithm in the whole city. Sometimes it's also the controller, which is too old and cannot run the code. But let's say it is a nice problem to optimize, and that's why people do machine learning here. And there is the project Flow, which is an interface to SUMO, which tried to set up some benchmark problems you can see here find good controllers for the autonomous vehicles as well. And so not only traffic light optimization, but also vehicle steering optimization. And there are people doing this with RLib. Lara Kodeka here, who also developed very nice large-scale simulation scenarios for SUMO, so for Monaco, for instance, or for Luxembourg. Also shares her RLib, her SUMO utils to do reinforcement learning with SUMO. Okay, so what else is there? So when I'm talking about, let's say, more or less external contributions, as you saw in the beginning, most of the time SUMO is used with the SUMO GUI, which is basically a two-dimensional GUI, but of course the world is three-dimensional, and people want to see it in 3 dimensions. So there are several implementations. So the SUMO Web 3D was something done at Sidewalk Labs, actually, and but I don't think it's developed further still. There are several couplings from SUMO to Unity. So there is an implementation of coupling SUMO to Carla. So what people do a lot is with SUMO is to use it as a source for surrounding traffic when they have an ego vehicle and they want to have not only a realistic environment concerning the buildings and trees and things like that, but also traffic around them. Of course, they always focus on the detailed simulation on their single vehicle, but to have all the vehicles around them, there are several couplings. I just mentioned Carla here because it's open source, but also couplings to CarMaker and RF Pro also did this. So many people who just want surrounding traffic try to do this with SUMO. This is the Carla coupling, which is using the Unreal Engine. And of course, also we at DLR do this. So this is, let's say, our individual car simulator, which is really, a big machine standing in Brunswick Of course, it's a Volkswagen inside, and because Brunswick is very close to Wolfsburg, and they do, let's say, simulations of the environment and very detailed 3D simulations, and but also use to simulate the surrounding vehicles. They use SUMO. Okay, so how does this continue? Also, if we look at the Eclipse environment, so we are not the only mobility-focused project in the Eclipse Foundation. There's more to it, for instance, Eclipse Mustang, which is, let's say, somehow a simulation middleware or a simulation connector, which does the co-simulation of different functionalities. So basically, a single vehicle flow, communication, and assistance systems, so the ADAS functions, can all connect to this middleware, to this backbone, and let's say get share their data there. And everything is embedded in the Open Mobility Working Group, which is, if you want, our substructure inside of the Eclipse Foundation. So if you want to influence a little or just talk to all the people using SUMO from the industry side, and also influence where everything is heading to, so this is the place to go. So the Open Mobility Group is somehow, let's say, the steering committee, if you want to, for the development of the simulation tools. Not only SUMO. SUMO is the largest project of this group, but also the Mustang you saw is developed by Fraunhofer Focus mainly, and Bosch and Vector are also part of this working group, and we regularly talk and try to find out what helps industry and also research organizations most to get the most out of it. Okay, so this was the talking. Now we can try it out if you want to. So if you downloaded SUMO and had a successful installation, then you can try now the SUMO Web Wizard. So if you are on Windows, you should have something in your start menu which says OSM Web Wizard. If you are on Linux, it should be somewhere in the tools directory of your SUMO installation. So somewhere user share SUMO tools, for instance. So I can just show here, where's mine? So here's my OSM Web Wizard. So this is for most people the starting point when they use SUMO, because if you double click this one, then you end up with a view like this. This is basically OpenStreetMap, just with a sidebar where you can, let's say, do some adaptations to your model. And so you can now zoom in, zoom out here. And you can also search for your favorite locations. And then only very few adaptations here, so that it's very easy. For instance, if you want to import public transport, then you can select it here. You can select the vehicles you want to insert, so only cars or trucks. So this is basically, the count is basically the number of vehicles per hour and street kilometer. and it will be randomly generated. So of course, OpenStreetMap does not contain a real traffic demand, so we need to generate it randomly. Then you can push the generate scenario button, and if you all push it at once, then probably the OpenStreetMap server will say it is too much, but maybe not. So it will now download the map to your local machine and generate a SUMO scenario. And the public transport and also the cars. So we did select nothing else here currently. And then it will open up and you have your first SUMO scenario. And you can already press the play button here and at least something will move. So everything is, of course, here. So the traffic is completely randomly generated, but the network should be more or less realistic. As you can see, it also does quite a good job. So you have some high quality OpenStreetMap data, as it seems, in Mountain View, California, because it does a quite good job also on bigger junctions. So sometimes you have a problem if you have junctions like this one, that they are made of very many small OpenStreetMap junctions, but this one is merged nicely, I would say. So the traffic flows quite well, and it also has public transport.
How do you understand the traffic control? Because I see some of the more complicated intersections are going to be partly managed in a fairly complicated way, or I'm not sure, maybe it's fairly standardized how traffic lights work in these, I'm seeing the upper right corner as a bit of a non-trivial intersection.
So maybe the sound was not optimal, but so the question was, how do we know about the intersection types? Or about
exactly, yeah.
Yeah. So in OpenStreetMap, it is labeled whether it is a traffic light or a priority intersection. Unfortunately, it's not always, let's say, an annotation for the intersection, but rather a traffic light pole, which is mentioned here. So and you have to decide. And SUMO has to guess whether it belongs or to which intersection it belongs. And yeah, but most of the time it works quite well. What, of course, we cannot guess here is if you have, so which kind of control it is. So of course we have different traffic light controllers in Europe than in the US, for instance. But at least we can. So you can afterwards manually change the type of traffic light and the type of traffic light control. So we also can do ring barrier controllers, for instance, which you have, I think, a lot in the US, and not so much the, let's say, rather traffic light phase-based system we have here. Yeah.
Okay, and is there a way of, so you can infer routes from data. Is it possible to infer the traffic light from data? Or maybe how do you do that backwards inference? Maybe that's the better question.
So usually when we do traffic lights, we do actuated traffic lights first. So we try, so most of the time we just try to let the traffic flow influence the switching of the traffic lights, because most of the time this already gives a good realistic result. But if you really want to have the very exact timing as it is in the real world, then most of the time there's nothing but either going to the city and asking for the plans, or taking a stopwatch and going to the junction, because there are a large variety of controllers out there. I mean, we have some interfaces to existing controllers here, which are here used in Germany from Schlotauer and Siemens and companies like that, which already do interfacing with SUMO. But the problem is always that those companies, sit on their IP. I mean, they do not want to open source anything, not even the interfaces. I mean, if they do not want to open source control algorithms, sometimes I cannot understand, because sometimes they're really simple, but of course they do not want this, and they do not even open source the interfaces most of the time. So even if you have implemented your own algorithm on their controller, most of the time you cannot connect it to SUMO without buying a license. I mean, it's not a technical difference, because the interface is already there, but you still have to buy the license from the company.
Right. So looking more generally, it seems like you can, with evidence from traffic counts and maybe get routes from GPS tags, you can infer it sounds like you can infer the likely distribution of routes, right?
So it depends which. So we do this from a variety of data. So what we do not so much actually is really individual trajectories. So if you have many GPS, so if you have detailed GPS data points for a lot of individual vehicles, then most of the time you cannot make very good use of them because in many cases they interfere with what the simulation is actually trying to simulate. So most of the time, if you get the detailed data, unfortunately we throw away a lot of it, because we only take the origin and destination matrix out of this data and then recalculate it. Because it is hard to tell if you know that the vehicle was at this location. It was on junction street A and street B at 12 o'clock, but your simulation now says, yeah, it is 12 o'clock, but it's still 2 junctions early or already 2 junctions later on its route. So what do you want to do then? So merging the simulation state with the measured state online is a hard problem in this case. So that's what we usually do, is to say, okay, we want to represent the traffic state on average. So we want to have the correct volumes on the streets, let's say on an hourly level, but we do not want to model all trajectories of all vehicles for the whole day. Or at least we want to model it, of course. You can take it out of the model, but we do not want to exactly replay the data.
Right. So what's the benefit of being precise about the individual vehicles? And I guess concretely, what kind of models do you use for individual driving behavior? What are the limitations? Like, what are the bounds of how accurate you're capturing, people's psychology while driving?
Okay. So we try. So since our aim is to have whole cities, we of course have a limitation in the precision of the individual vehicle. It depends on how people do this. So there are different car following models, for instance, in SUMO, and sometimes people say we want to have it very precise on a single junction. So they calibrate really the acceleration behavior on a green light and calibrate the single model to it. And sometimes people say we only want that it is correct, that the flow is correct on average, and they don't do this as detailed. So it really depends on what you want to do, but usually we say if you want to model, for instance, things like evasive behavior, that there's a blocking on the street and the car just doesn't stop but tries to find a way around it. That's something we, for instance, do not do in SUMO. But cars still stop if there is something blocking. But most of the time they do not know, or if the lane is blocked, then the car stops, basically.
Right. Cyrus, you had a question?
Yeah, I was wondering if SUMO can be used to model collisions or rates of collisions, or do, like, for example, a virtual experiment where I change yellow light duration or speed limit or a merge length and find out what the safety implications are for that change.
So yes, people do this, but as I just said, we have no realistic evasive model, basically. So we have, let's say, safety surrogate measures, which you can also take out of SUMO. So things like post-encroachment time and what was the minimum distance or the difference in speeds of the vehicles. And people also calibrate this or model things like what would happen if I do not see the conflicting stream. So how many critical situations would I generate? Well, things like that is something people do, but not. So we can probably not take something out of as how severe would the accident be, because we have no really physics engine behind it.
Okay.
And Purvi had a question?
Yeah, I was wondering about the point you had about homogeneity of traffic versus heterogeneity in like more populated areas. So how does interaction from real world data vary in those cases? For example, where there is high unpredictability. For example, I'm from India and it's really hard to predict what's going to happen on roads at any time because people are just coming to roads at any time. But here it's more systematic in US and there's a lot more predictability what different drivers are going to do. So how do you basically model the heterogeneity among different traffics, and is there more real-world interaction in those cases?
So the basic approach is a so-called sublane model, so that we subdivide the lanes on our streets into smaller areas, so that a vehicle which is on one lane, or a vehicle which is somewhere on the street, does not block the whole lane, but there can still other vehicles go around it, or persons. And so they all can share the street, and you can have, four or five vehicles side by side although there are only 3 lanes. So in a sense, the vehicles still try to find their way in a direction. So we have still a predictability in the sense that no one will ever go backwards, for instance. So they all have an origin and a destination, and try to follow their path to reach their destination, and will not take very large detours, for instance, to find this. So it is not like a robotic model where you could just do a free path planning in the 2D plane. So that's not what we do. So in a sense, it is still much more predictable than what probably happens in real life. But at least you can, in my opinion, have a good model of it's a much denser traffic situation, and the possibility of overtaking and finding your way through, even if it's not a complete lane you need.
Cyrus?
Yeah, one more question. You mentioned at the beginning that the target user sort of went from computer scientists down as you built a GUI. And I'm wondering who the least technically sophisticated users are that you can support. So, for example, in my local community, we have city council members who are arguing over, will this change for multifamily housing result in traffic congestion, on this arterial? And they are not, computer scientists at all. How far down the technical savviness can you accommodate users?
Yeah, it's hard to tell for us, actually. So if you want to do a simple model, I just showed you, you can do it with 3 clicks here. Yeah, it's always hard to tell for the computer scientists what the non-computer scientists can really do.
Is there,
I would say,
is there an effort toward making this tool accessible for more and more less technically savvy people, or yeah?
Yes, there is, and people do this, but most of the time they're trying to do this with SUMO, so we're really hiding then SUMO as a backend. So I don't know if you know about AB Street. Dustin Carlino that did a simulation of Seattle. And he has a very, very simplistic traffic model, but he has a very nice graphical user interface and a very easy to use one. And we already asked him, and he did also a presentation at the last SUMO conference. So whether this would be an option for us to have, to couple his front end to our back end, basically. Mm-hmm. So I think it will go more into this direction, because we are more the traffic modelers and not the graphical user interface people.
Yeah. And I think it's probably not just the interface as well. It's getting the data. It's getting access to demand data and like having that all come in automatically, so the user can just use it easily.
Yeah. So we want to do something in making it easier also to get the demand into it. I think the larger problem is to have a nice user interface for really editing the map. So for things like, I want a bike lane here, things like that. And then what you currently need to do with SUMO is you can go into net edit, then add the lane, but then you need to recalculate all the routes, or not if you add a lane, but if you split an edge, for instance, then all the routes can get invalid because the edge IDs change. And then you need to recalculate them, which is another 2 clicks, and come back into the simulation, reload the simulation. So yes, it is not the most friendly way yet. And this is, I think, what AB Street, for instance, does a lot better. But yeah, they have only a model which says basically, oh, there's a vehicle popping up here. It will need 20 seconds until it pops up here. That's their traffic model.
I would recommend SimCity or City Skylines. If you ever connect to them, the amount of insight people can get will be enormous.
Yeah, okay, SimCity. There are open SimCity clones as well, I think. Yeah.
Oh, that'll be good. Yeah, like I use City Skylines as a game, and like just learning how traffic really works would be fantastic. And they have some model, but a realistic one looks just like the city could say, "This is our town. Learn how difficult this is." Public communications. All right. Well, yeah, this is fantastic. Thank you very much. It's a wonderful tool.
You're welcome. So yeah, if you have more questions or want to know more details about the one or the other application, then just give me a call, send me a message. We have, I think, is this on the slides? We have also a MetaMost channel or a mailing list where you can ask for more information. So there it is. Okay, so we have the web widget. There it is.
Perfect. Yeah. And yeah, send me your slides.
Yeah.
I'll send them around internally.
Okay.
All right, great. Well, yeah, thank you very much. Have a great evening.
Thank you.
Thanks.
And a nice day to you. Okay, bye.